Yeah, online students, I've shared my screen. Is it visible?
Yes, ma'am.
Okay. All right. So
Yes, ma'am.
continue. Yeah, good. All right. So as I told you, we are continuing with exponents. So see this question, solve for m. 4 by 7, the whole power 3m divided by 4 by 7, the whole power minus 6 is equal to 4 by 7, the whole power minus 9. So you have an equation here because you can see the equal to sign. You can see the equal to sign. So you have an equation. There's an equation. This is the left hand side. This is the right hand side. This is the left hand side. This is the right hand side. We have an equation. Now we need to solve this equation and find the value of m. We need to find the value of m. So again, using the law of exponents, okay, when bases are same and its division, we subtract the powers. So 4 by 7 is a common base in the left hand side. In the left hand side, the common base is 4 by 7. And you can see the operation is division. So we have to subtract the powers. So write the powers. 3m is one power, minus 6 is the other power. Subtract the powers. You need to put a minus sign in the middle. 3m and minus 6 are the powers. You subtract it. So you put a minus sign. Is equal to, on the right hand side, there's nothing to simplify. So 4 by 7 to the power minus 9 as it is. Now here 4 by 7 in the left hand side, 3m plus 6, because minus into minus is plus 6 is equal to 4 by 7, the whole power minus 9. Now you can see how this equation looks. There's an equal to sign. In the left hand side, there is only one base raised to some power. And on the right hand side also, there's only one base raised to some power. At this stage, it should look like this. When it looks like this, that is, how should it look? Equal to sign. On either sides, you have the base, the same base 4 by 7 raised to some power, any power. Now here we say, since bases are same on both the sides, we equate the powers. See here, base 4 by 7, base 4 by 7 on both the sides. So you equate the powers. That means just ignore the bases. It's like, don't cancel. It's like 4 by 7 on either side gets cancelled. You're not actually cancelling it. Okay, so ignore the bases. So since the bases are same on both the sides, equate the powers. So that means 3m plus 6 is equal to minus 9. 3m is equal to minus 9 minus 6. 3m is equal to minus 15. M is equal to minus 15 by 3. M is equal to minus 5. The value of m is minus 5. Yeah, right on, children. This is what I just explained. Write this one first. I'll explain this one also. Don't see this now. I'll explain this. Don't see this now. This is what we just understood. Write on this.
Finish, ma'am.
Yeah.
Ma'am, I'm having a doubt, ma'am.
Yes, Smriti, with the first one.
Yes, ma'am.
Yeah, what's your question?
Ma'am, we are cancelling out the 4 by 7, ma'am.
No. I told you, you should not cancel. See the reason here. Bases are same on both the sides. So equating the powers we get. We equate the powers. 3m plus 6 is equal to minus 9. I just told you, it's like you're just cancelling this. So what are you left with? 3m plus 6 is equal to minus 9. You should not actually cancel it.
Okay, ma'am.
Yeah. Now on the other side, you can see a different working. So that goes like this. Now the rational number is 4 by 7. The base is 4 by 7. So you can have 4 by 7 throughout, or you can also have 7 by 4 throughout. Okay, you can have the base 4 by 7 throughout, or you can also have 7 by 4 throughout. Now, because sometimes we feel when the power is negative, we'll make it positive. Sometimes we may feel that. Actually, you don't have to do it. See, this working is fine, children. I'm just telling you how to handle. If you started like this, then how do you proceed? So supposing you thought the powers are negative and you wanted to make them positive. Okay. So then you write this 4 by 7 to the power 3m as it is. Are you all listening? Are you all interested in listening to the alternate solution?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yeah. So you can see here, supposing you thought, the power is negative, so you wanted to make it positive. How do you do that? You'll have to write the equivalent. How do you write the equivalent? Reciprocal of the base, negative of the power. So 4 by 7 becomes 7 by 4. Negative of the power, minus 6 becomes plus 6. Equivalent. Now here, reciprocal of the base, 7 by 4. Negative of the power, minus 9 becomes plus 9. That's the first step. See, now with what idea have we done this? Supposing we feel negative powers must be made positive, then you wouldn't be disturbing this. So you write that as it is. And then here, since the powers are negative, you may want to write it like this, equivalent, reciprocal of the base, negative of the power. So like this, you write the first step. And then you realize that, oh my God, I have 7 by 4, I have 7 by 4, but this is 4 by 7. So since we have 7 by 4, base 7 by 4 here, then you just want to make this 4 by 7 also 7 by 4. So then what you have to do? You have to take the reciprocal of the base 7 by 4 and write the negative of the power. So it will become minus 3m. It's becoming negative, but you have no choice now. Because you started like this, you have to do this. See, whether positive or negative powers, it's fine. It's fine. So since you took this decision here, here the bases are 7 by 4. So you have to make this also 7 by 4. So then it becomes reciprocal of the base 7 by 4, negative of the power minus 3m. Now it looks like this. Now it looks like this. So now how do you understand this? Bases are same. In the left hand side, don't take all together, children. Don't take all of it together. There's an equal to sign here. You cannot take all of it together. You can take only the LHS and the RHS. You have to take the LHS and the RHS separately. So in the LHS, what you have? Only these two. Bases are same, it's division, subtract the powers. So 7 by 4 is the base, subtract the powers, minus 3m, minus 6. I've written the powers in brackets and taken a minus sign in the middle, indicating subtraction. Is equal to here in the RHS, there's only one thing, no? So nothing to be simplified there. So write that as it is. Again, coming back to the LHS, the left hand side, minus 3m minus 6 is equal to 7 by 4 to the power 9. Now you see that there's an equal to sign. There is one base 7 by 4 power. That is in the left hand side. In the left hand side, you see that there's only one base raised to this power. In the right hand side, the same base 7 by 4 raised to a different power. At this stage, you can use this rule. What's the rule? Bases are same on both the sides, equating the powers we get. It should look like this. Only in this stage, you can use this rule. So what do you get? Minus 3m minus 6 is equal to 9. Minus 3m minus 6 is equal to 9. And on solving this, you get m is equal to minus 5. So you see that the value of m is the same, should be the same. So if you're working it, using the rules correctly, you will get the same answer, however you do it. You have to take down both the workings, children. I want you to write down both.
Yes, ma'am. Understood and written.
Now, in less than a minute, okay, 1 minute. Have you all finished?
Yes, ma'am.
Yes, 1 minute.
Who's still writing? Gayatri, yeah?
Ma'am, Aishwarya. She
Okay.
did.
Okay. Done, all of you?
Yes, ma'am. Done.
Okay, now, online students, go grab a phone, take a picture of this answer from your notebook and send it on WhatsApp in less than a minute. I need to make sure that all of you are writing.
Yes,
You
ma'am.
can send it from a different number also. It's okay. If I don't have that number, send it on WhatsApp. Maybe a new number also, you can tell me that you have sent from a different number. I want it in less than a minute. Now don't scribble in your book. I can make out from the handwriting if you have not written it. Yes, I get it from Anintika first. Very good. Oh my, that's so neat, Anintika. So nice. Oh my God. Oh my God, you cannot write so neatly. So nice. Very good, Anintika.
Thank you, ma'am.
Excellent. So nice. So happy to see this. Very nice. Yes. Gayatri. Got it from Gayatri. Where's other working, Gayatri? No, Gayatri, no, I don't think you've been working. See? நான் என்ன எழுதியிருக்கேன் உன் புக்ல என்ன இருக்கு 4/7 தனித்தனியா எழுதியிருக்க No. Not happy, Gayatri. Next, Aishwarya. Aishwarya, bracket போடல நீ. See the first column, Aishwarya, 4/7. Use the bracket.
Yes, ma'am.
And see, where are the steps, Aishwarya? You've just worked. It's okay, you've done it by yourself, but whatever steps you see on your screen, They're all mandatory. Nothing is extra. All this must be in the paper to get full marks. Your steps carry marks. And see, you have not used the bracket. 4 by 7 bracket to the power 3m plus 6. And that doesn't look like 3m plus 6. It looks like 3m minus 6 also. Why, Aishwarya? அப்புறம் ஒரு இடத்துல m looks like n. In the next step, see, 3n plus 6 is equal to minus 9. Your m looks like n. I think your pen, there's some trouble, meaning it's not writing continuously, I think. Everywhere you've missed the brackets. Not very happy with your work, Aishwarya. Kindly rectify in the classes to come. See, Aishwarya, what I see you're working is, sorry?
I'm sorry, ma'am. I'm just gonna add the brackets and change.
Yeah. So see here, this bracket you have not written. Nothing is extra here. You cannot find out anything that is extra here. Everything is compulsory. Everything is mandatory. This bracket is important. I'll tell you why. 4 by 7 to the power 3m. You know the meaning? This 3m is only for 4, not for 7. If you write 7 by 4 to the power 6 like this, see, first is, it's all hanging in the air. Actually, there is nothing. This has no meaning in the first place. This has no meaning in the first place. If you write a 6 like this, at least you should have written it like 7 to the power 6 by 4. If you write 7 by 4 and somewhere in the air 6, there's no meaning. At least this one makes some sense, like 7 to the power 6 by 4. Now, when we write 7 by 4 to the power 6 like this 6, okay, it can be for the numerator, not for the denominator. That is why we use a bracket. When we use a bracket and then write 6, that means the 6 is for both the numerator and the denominator. Sai Smriti, I've not got it from you. Sai Smriti. Okay. Now the next one. By what number? Any doubts, children, with this one? Shreya? By what number should 3 by 5 the whole power minus 2 be multiplied to get 3 by 10 to the power minus 1? Right? Okay. So let the number to be multiplied be x. Let the number to be multiplied be x. By what number? Don't write anything now. By what number should this one be multiplied? So we have 3 by 5 the whole power minus 2. We need to multiply this with something like x to get 3 by 10 to the power minus 1. We need to first construct this equation. 3 by 5 the whole power minus 2 is multiplied by x to get, meaning equal to 3 by 10 to the power minus 1. So once you construct this equation, you just have to solve for x. You just have to solve for x. So now, this one, when it goes to the other side, now we are solving for x. So you need to have x alone on one side and take this to the other side, right? Meaning, which one to the other side? This one. This one is to be transposed. This one is to be transposed. So it will come to the other side for division, right? So it will be divided by 3 by 5 the whole power minus 2. Is this correct? What is in multiplication?
Yes,
There will come for division on the other side. So it will be divided by 3 by 5 the whole power minus 2. Now x is equal to, now what is 3 by 10 the whole power minus 1? It is reciprocal of the base, negative of the power. Now here you need to first change this division sign to multiplication. That is important. You can never proceed with the division symbol. You should change this division to multiplication. Then if you change this division to multiplication, you must write the reciprocal of this one. Division becomes multiplication. Then you should write the reciprocal of this. What is the reciprocal of this one? Reciprocal of this one. Reciprocal of that is, you can write the base 3 by 5 as it is and write the negative of the power. So x is equal to 10 by 3 into 3 by 5 into 3 by 5. 3 by 5, the whole square is nothing but 3 by 5 into 3 by 5. Now simplify. 3 and 3 gets cancelled. 5 ones are 5 twos are. So the required number is 6 by 5. X is equal to 6 by 5. X is equal to 6 by 5.
I solved it another way, but the answer is still the same.
Yeah. See, even I have done it in 2 ways. Yeah, you
Okay,
can do it.
So should I note down the other way?
What do you feel?
I think I should write.
Okay. No, actually, see, one method you've understood clearly, that's enough. Instead of, anyways, you have to wait for your friends to complete, right? So in the meantime, even you can finish it.
Yes, ma'am.
Yeah. I think the method which I explained is here. This is the method which I explained. Again,
Yes,
you can do it in different ways, children. Please have a look at both. Or maybe if I explain it, then it will be more comfortable for you to write. 1 minute, 1 minute. Sorry. Since you can do it in many ways, 1 minute, children. Let me just explain this. See, what I did here is correct. What I explained here is correct. But I have not presented that here. So let me explain this. Now here, as usual, this is the equation. 3 by 5, the whole power minus 2 into x is equal to 3 by 10 to the power minus 1. So here, what have I done? So I've this is the power is negative, right? The power is negative. So I've made it positive. Write the equivalent. So 3 by 5 becomes 5 by 3. 3 by 5 becomes 5 by 3 and minus 2 becomes plus 2. Into x is equal to 3 by 10 to the power minus 1. Reciprocal of the base 10 by 3, negative of the power 1. Write the equivalent for both children. I have written the equivalent for both, for this as well as this. Then what is 5 by 3 the whole square? 5 by 3 into 5 by 3 into x is equal to 10 by 3. So x is equal to 10 by 3. How do you work this? These fractions will go as reciprocals to the other side, right? 5 by 3 will become 3 by 5 here. 5 by 3 will become 3 by 5 on the other side. Yes or no? Fractions will become their reciprocals on the other side. X is equal to 10 by 3. 5 by 3 on the other side will become 3 by 5. So on simplifying, you get 6 by 5. So here, this is the first step, the equation. And what have I done here? Here I have transposed. This is in multiplication here. So when transpose, it goes for division to the other side. So I've written this x is equal to this one as it is. Now this when transpose divided by 3 by 5 to the power minus 2. It goes for division. When you take this here, it goes for division. So divided by 3 by 5, the whole power minus 2. That's the first. That's the next step. Then what have I done? I've written the equivalent of this. So again, see children, see there are different ways. Now don't tell me See, this is one of, you can simplify in so many ways, meaning what I've done here is the power is negative. So I've made it positive. So 3 by 5 to the power minus 2. Equivalent is 5 by 3 to the power 2. I've done that. I've done that here. Then after that, I've written the value of 5 by 3 the whole square. What is 5 by 3 the whole square? 25 by 9. See, when should you write the reciprocal? Only when division sign, you change it to multiplication, you must write the reciprocal here. Otherwise, you should always write the equivalent only. That is reciprocal of the base, negative of the power. When to write reciprocal? Only if they ask you to write the reciprocal, or which is the other situation in which you have to write the reciprocal. Only when division becomes multiplication, you write the reciprocal of this one here. In all other situations, you write the equivalent. So 5 by 3 the whole square, the value is 25 by 9 because 5 by 3 into 5 by 3 is 25 by 9. So now division becomes multiplication and 25 by 9 becomes 9 by 25 on simplifying 6 by 5. I think this one, children, instead of blindly copying, let me share this slide with you. You can write it later. You forget it and so that you can do it in your own way. You forget it now. Now it will just be blindly copying, no? I'll share this slide on WhatsApp with you. You can write it later. Leave some space. Write the question. Leave sufficient space to write the answer. Please write the question. College. This is by what number should 1 by 2 to the power minus 1 be divided? By what number should this one be divided? So let this one be divided by x. So that the quotient is minus 4 by 7 to the power minus 1. See, when you divide 27 by 3, what is the quotient? 9. So you write the quotient here. See, when you divide 60 by 12, what is the quotient? 5. So 60 by 12 is equal to the quotient 5. This is how you write the equation. Correct? You write the quotient here. You write the quotient here. So 1 by 2 to the power minus 1 divided by what will give the quotient minus 4 by 7 to the power minus 1. So now what can you do? 1 by 2, we can make it 2 by 1 and write minus 1 as plus 1. Division becomes multiplication. X becomes 1 by x is equal to, and here also a reciprocal of the base minus 7 by 4, negative of the power 1. So this is nothing but 2 into 1 by x is equal to minus 7 by 4. So 1 by x is equal to minus 7 by 4. What happened is 2 here on the other side, children?
It will divide
by 1 by 2.
Into 1 by 2. 2 by 1 will become 1 by 2 on the other side. 2 by 1, no, because 2 means 2 by 1. That will become 1 by 2 on the other side. It become 1 by 2 on the other side. So 1 by x is equal to minus 7 by 8. 7 1s are 7, 4 2s are 8. Now taking reciprocals on both the sides. See, like if 1 by a is 2 by 5, then a is equal to 5 by 2. For example, taking reciprocals on both the sides. Taking reciprocals on both the sides. If supposing you have 1 by a is equal to 3 by 5, then a is equal to 5 by 3. So similarly here, 1 by x is equal to minus 7 by 8. So x is equal to reciprocal, minus 8 by 7. So the number by which it should be divided is minus 8 by 7. All right, children?
Yes,
Minus 8 by 7. Yeah. So just write the question. Leave some space. Yes, Smriti, let's do it again. Tell me how to work this.
Yes, ma'am.
Why don't you send your
2/1.
picture, Smriti?
Ma'am,
I wanted you to share the picture of the answers, right? Why you didn't share?
ma'am, can I do it now and share it now?
No, no, no. Time up. Now I don't want to see. I asked you to share sometime back. No, why I didn't receive? Not now. Now it's late.
Yes, ma'am.
No, why didn't you send?
No, ma'am. The power
You didn't
went
write.
on, ma'am.
Sorry?
So I rejoined the meeting.
Okay. All right. Yes, Smriti. Tell us how to do this.
Yes, ma'am. 2/1 whole power 1 into 1 by x is equal to minus 7 by 4 whole power 1.
Okay.
2 into 1 by x is equal to minus 7 by 4. 1 by x is equal to minus 7 by 4 into 1 by 2.
How 1 by 2?
Ma'am?
How 1 by 2?
Ma'am?
Why is it 1 by 2? Why is it not 2? It's
Because
2 only,
2
no,
into
here.
1 by x, ma'am.
No, it's 2 here, right? So it will come as 2 to the other side. Why 1 by 2?
Ma'am, 2 into 1 by x. So 1 by x is equal to minus 7 by 4 into 1 by 2.
That's what I want you to explain, that into 1 by 2. How do you get into 1 by 2?
Ma'am, is it 2 by 1?
No, you said, okay. Aishwarya,
Yes, ma'am.
is it into 1 by 2 or 2 or what is it?
Ma'am, when we're writing 1 by x is equal to minus 7 by 4, it will become 1 by 2 because you're taking the reciprocal when you're taking it to the other side.
Okay, what is it on this side? What is 2 on this side? 2 means what here?
It's multiplied with 1 by x.
No, 2 means 2 by?
1. 2 by 1.
Yeah, 2 is 2 by 1. So it's reciprocal is?
1 by 2.
Yeah. So 2, whenever you take a number, it's in product here. When you take to the other side, it becomes its reciprocal. So into 2 by 1 becomes 1 by 2.
Yes.
Yeah, then continue, Aishwarya. 1 by x is equal to?
1 by 2. Then you have to multiply, which will be minus 7 by 8. So then we have to take the reciprocal to find x. So it will be 8 by minus 7.
8 by?
Minus 7.
Or minus 8 by 7. So the rule there is taking reciprocals on both the sides.
Yes.
Taking reciprocals on both sides. See, you cannot take, children, you cannot take the reciprocal in this case. See here, I'll tell you. Now, supposing we have okay, 1 by 2 plus 3 by 4 is equal to okay, 1 by x. 1 by x. Now you cannot take reciprocals on both the sides and say 2 by 1 plus 4 by 3 is equal to x. This is wrong, because to take reciprocals on both the sides, you should first simplify this and make this one fraction. See, like this it should be. There's only one fraction here, one fraction here, and equal to sign. Now you can take the reciprocals on both the sides. So here this is 1 by 2 plus 3 by 4. You should simplify that and make it one fraction. Then you can take the reciprocals. It should look like this. To take reciprocals on both the sides, you must have one fraction here and one fraction here like this. Single fractions or single rational numbers like this, 1 by x is equal to minus 7 by 8. So like numerator by denominator is equal to numerator by denominator. Now you can take reciprocals on both the sides. If you have something like 1 by 2, okay. If you have something like 1 by x is equal to 1 by 2 minus 3 by 4 plus 1 by 5, you cannot say x is equal to 2 by 1 minus 4 by 3 plus 5 by 1. This is wrong. You have so many fractions here. You cannot take the reciprocals. So you must simplify this by taking the LCM and get one fraction. You must get one, simplify this and get one fraction. Now take reciprocals on both the sides. Supposing you get some 11 by something like 20 here. So x is equal to 20 by 11, like this. Okay, write this question, leave some space for the answer.
Yes, ma'am.
Yeah. So now we'll learn how to write decimal numbers in the expanded form. I think this you should have seen last year. Just have a look at this, children, and let me know if you know it already.
Yes, ma'am. We studied it last year.
See this, Shreya? Are you aware of this? No. What about the others?
Yes, ma'am, we have done the similar type questions last year.
Excuse me, ma'am.
Yeah.
Ma'am, I've just watched only one video, ma'am. So first video, first session only I completed, ma'am.
Yeah. So because you missed the first two sessions, it may not be easy to understand. The first two sessions have the, the entire idea of the laws of exponents and, how you handle how you change an expression with a positive numerator to negative with a positive power to negative power, many things we learn in the first two sessions. So what do you want to do? You want to continue now or you will watch the recording? I'll share the recording.
No, ma'am, I'm having the recording, ma'am.
Sorry?
I'm having the recording, ma'am, but I've not watched it, ma'am.
Okay. Fine. No, I'm asking you, do you want to stay in today's meeting or you will leave and I'll share the recording, today's recording?
No, ma'am, I'll just stay here.
Okay, fine. All right, children. So see the place values. This is hundreds, tens, ones. 10 to the power 0 is 1. Ones, tens, hundreds. We write in words, no? ONES, ones, tens, hundreds. Same thing, using exponents. This is ones. 10 to the power 0 is 1. This is tens. 10 to the power 1 is 10. Hundreds. 10 square is 100. Okay, decimal point. This is the tenths place. Tenths. Tenths meaning 1 by 10, which is nothing but 10 to the power minus 1. After the decimal point, it is tenths. The place value is tenths, which is nothing but 1 by 10, which can also be written as 10 to the power minus 1. The next one is hundreds. Hundreds. THs. Write 100 and add THs. Write 100 and then THs, which is nothing but 1 by 100. This is just 100. No, this is 1 by 100. Or 1 by 10 square or 10 to the power minus 2. Then you have the thousandths place, right? 1000 and then THs. Thousandths is equal to 1 by 1000. On the other side, you have thousands, which is 1000. This is thousandths, which is 1 by 1000, which is 1 by 10 cubed, which is 10 to the power minus 3. And so on. Let me write that here. Decimal point. Okay, ones, tens, hundreds, thousands, and so on. After the decimal point, it is 1 by 10, 1 by 100, 1 by 1000, and so on. This one is, I'll just write one example here. So this one is 1000, A and D. Here it is, write the same thing, 1000, THS, thousands. This is 100, RED. This is HUND, RED, THS, hundreds. This is TN. This is TEN, THS. This is ones or units or whatever you call it, This is a decimal point. So this 1000 is nothing but 10 cubed. This is 10 square. Okay. And this is 10 to the power 1. And this is 10 to the power 0. 10 to the power 0. Decimal point. 1 by 10 is nothing but 10 to the power minus 1. Okay, 1 minute, 1 minute. Let me just write something else. Okay, so this is nothing but 1 by 10 to the power 1. And this is nothing but 1 by 10 square. And this is nothing but 1 by 10 cubed. Okay, so this one as it is 10 cubed, 10 square, 10 to the power 1, 10 to the power 0, decimal point. When this goes up to the numerator, it will be 10, reciprocal of the base, negative of the power. Reciprocal of the base, 1 by 10 becomes 10. Negative of the power. Reciprocal of the base. Yeah, equivalent you should write. Reciprocal of the base, 1 by 10 becomes 10 by 1, 10. Negative of the power. Reciprocal of the base, negative of the power. Okay, so this is the decimal place value chart. When you have digits after the decimal point, this is how the place value chart looks like. When we have digits after the decimal point, this is how the place value chart looks like. All right. You can take a picture of this or you can write this now, children. Okay, quickly make a note of this. You can make a beautiful table. See, I've not done that. You can make a beautiful table out of this. It goes on. It goes on. Doesn't end here. It goes on this way and this way.
Yes, ma'am.
Yeah. I'll let you do. Please maintain your notebooks, children. Having a separate book for every chapter will really be useful. So if I do some revision now, supposing, say after a few months, we go back to rational numbers for some revision, you can pick that book and continue working in that book. So you will have all about rational numbers in one place. So if you have one book for, a few chapters, then when we're revising certain chapters, you will have everything in between. So you may not be able to revise everything of that particular chapter. So maintaining different books for different chapters will really be useful. So when we come back to a chapter, we finish a chapter, and after some days we come back, after a few months we come back to a particular chapter for revision. You can just pick that book and continue the revision there. So you'll have everything about one chapter in one book, in the same book. So when you're revising, you will not miss on any concept. You can be 100% sure that you have, revised everything. It's enough if you practice from the tuition notebook, children. Everything is covered. You don't use any other material. You should not be using any other material. Do not use any other, question bank or whatever reference books. Don't use anything. Practice only from your tuition notebook, only from this book. If you're thorough with this, then you can test your knowledge, by working questions from other books. I'm sure you will be able to do it. But before trying that, you should have practiced from the tuition notebook very well. Yeah, so this one, I'll just share a picture. I'll share this on WhatsApp. You can complete this later. Leave space accordingly, children. Leave some space accordingly. I'll share this image on WhatsApp. This is simple. You can write it later.
Mom, so when we're solving these questions, do we have to make the same table given here?
Not needed. Yeah. This is easy for me to explain. So I have put it in a table. Not needed.
Okay, ma'am.
Yeah. So you can just write it like this. So now, for example, this one. For example, the third one, just write the number 0.045 and you can straight away give the answer. So this one, you know that this is the ones place. This is 10 to the power 0. This is 10 to the power -1, 10 to the power -2, 10 to the power -3. So you don't have to write for the zeros. You don't have to write for the zeros. You can start with the valid digit 4. Okay, so 4 into 10 to the power -2 plus 5 into 10 to the power -3. It's enough if you present it like this. I'll write it again. 0.045. Before the decimal point, 10 to the power 0. After the decimal point, 10 to the power -1, 10 to the power -2, 10 to the power -3. You do not have to, write for the zeros. So we'll start with this 4 here. 4 into the place value, 10 to the power -2, plus 5 into the place value, 5 into the place value. That's it. This is the expanded form. We have done this when we were young, So 456, or this number in the expanded form, 4 into 1000 plus 5 into 100 plus 6 into 10 plus 7 into 1. We have done this. Maybe third or fourth standard, fourth standard. We have learned how to write a number in the expanded form. Yeah. So now this is putting a number back in the decimal form. It's given in the expanded form. In question number 10, we have 3 subdivisions. In all these 3 questions, you are given the expanded form of a decimal number. You will have to write this in the decimal form. That is the expanded form in the decimal form. So look at the place values. You can see 10 to the power 1, 10 to the power 0, 10 to the power minus 1, 10 to the power minus 3. So we'll also start from here, 10 to the power 1, 10 to the power 0. Then you'll have to complete. If you start from 10 to the power 1, you should write everything. You cannot miss anything in the middle. Just because there is no digit in a particular place value, you cannot miss writing that place value. You have to, if you start from here, you must continue to write everything. So after the, so you start, see, you start from 10 to the power 1. You start with 10 to the power 1. That's it. Now don't see this. Write everything after this. 10 to the power 1, 10 to the power 0, decimal point, 10 to the power minus 1, minus 2, minus 3. You must write everything. Now it's not that we don't have 10 to the power minus 2 here. So why should we write this? It's not like that. You must write all the decimal. You should write all the places. Just because we do not have 10 to the power minus 2 here, it doesn't mean you can ignore this. You should just know the starting point. You should start from here, 10 power 1. So then continue 10 power 0, decimal point, 10 to the power minus 1, minus 2, minus 3. Now fill the digits. 6 here. In this place value, 10 to the power 1, we have the digit 6. 10 to the power 0, we have the digit 5. 10 to the power minus 1, we have the digit 8. 10 to the power minus 2 is not visible. It's not here. So that means 0. It's 0 into 10 to the power minus 2. If there is nothing, it means 0 into 10 to the power minus 2. So 0. And then 10 to the power minus 3. In this place, we have the digit 3. So the decimal number is 65.803. 65.803. So the next one, you can only see 10 to the power 0 and 10 to the power, 10 to the power minus 2 and minus 3. But you cannot start from there. You should this is minimum. You must write 10 to the power 0 and the decimal point. See, we have written here 10 to the power 1 because we have a digit there. Otherwise, minimum requirement is this. You must start with 10. Just because there's only this and this, you cannot write only these two. You must start with 10 to the power 0 and write the decimal point. This is minimum. You should start from here. Or you can go ahead of this. Minimum is this 10 to the power 0, decimal point 10 to the power minus 1. So this is minimum. 10 to the power 0, decimal point minus 1, minus 2, minus 3, and so on. You cannot write anything less than this. Now here, see, we wrote here 10 to the power 0, decimal point, all this. But we wanted this also. You can add some more, but not less than this. Am I clear, children?
Yes, ma'am.
Okay.
Yes,
So here there is all right, children. Thank you. So here we have nothing. So 0 point. Here also we have nothing. Meaning in this place value 10 to the power minus 1, we don't find any digit. So 0. Then here 4. Here 5. So the number is 0.045. 0.045. So here you see 10 square. So you should start from there. 10 square. 10 to the power 2, 10 to the power 1, 10 to the power 0, decimal point, 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. We stop there because that's the last thing here. So here, and in this place value, we have 5. Yeah, you know now. Just fill. If there's nothing, put a 0. Otherwise, write whatever digit is found in that place value. And then the number is 504.096. Is that fine, children?
Yes, ma'am.
Okay. Okay, so it's time. So we'll do this in the next class. I'll share the required images on WhatsApp. Please finish your classwork. Please wait. Let me see if you can recall from Rational numbers. Orally, children, we are not working this orally. Yes, Shreya here, tell me what property. I'll read the heading for you. I'll read the heading for the class. Name the property of multiplication illustrated by each of the following statements. Name the property of multiplication illustrated by each of the following statements. Yes, Shreya, the first one. Commutative property. Correct? Commutative property of multiplication of rational numbers. Very good. Aishwarya, second one.
Ma'am, it's associative property of rational numbers.
Yes, associative property of multiplication of rational numbers. Associative because we can find three rational numbers here. 2 minus 2 by 3, 7 by 9 and minus 9 by 5. Very good. A third one, Anintika.
Distributive property.
Of
Distributive property of rational number of multiplication over addition.
yeah, distributive property of multiplication over addition. Distributive property of multiplication over addition because A into B plus C is equal to A into B plus A into C. Very good. Sai Smriti. Fourth one.
Multiplicative identity.
Multiplicative identity or multiplicative inverse?
Multiplicative identity.
Multiplicative identity. Agree, Shreya? Other girls agree with her? Multiplicative identity of rational numbers? Why does it take this long to agree or disagree? Yeah, she's right. Multiplicative identity of rational numbers. Yes, next one. Okay, not Gayatri, I'll not ask you. Who can tell me the next one, fifth one, Shreya?
Okay.
Sorry. Multiplicative inverse. Very good. Multiplicative inverse. This is the multiplicative inverse of rational numbers. The product of a number and its reciprocal. The product of its reciprocal and the number is 1. Multiplicative inverse. What about this one? Property of
Property of 0.
Property of 0. That's all. Property of 0. Property of 0. Very good. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Bye, ma'am. Thank you.
Thank you.
Thank
Good
you,
night.
ma'am. Good
Good
night.
night.
Thank
Bye,
you,
ma'am.
children.
Thank you. Good night.
Thank you, ma'am.
Thank you,
children.
ma'am.
Yeah, thank you. Good night.
Ma'am, I've